This video is going to be on lesson 2.3, which is the dot product. The last time that I had taught this course partially, a lot of people were like, what's the dot product, miss? And I explained it and they're like, no, seriously, what is the dot product? I don't get it. Okay, so I'm going to try to explain this as best I can, but it is a little bit difficult to understand. Okay, you guys ready? We have two vectors. We have vector v, and then we also have vector u. Okay, now I'm going to tell a little bit of a story. Pretend that you have a sun, and the sun is happy. All right? Now the sun is going to project and shine onto vector v, and it's going to create a shadow. V's shadow onto u. So imagine u is the ground, and it's going to project a shadow, so obviously the shadow is going to be kind of like this long. Okay? So what I need to do is I need to create a product, so product means multiplication, between two things. And the two things are the shadow, the one in red, and also the magnitude of u. So u is this long, and that is the magnitude. Okay? Now the thing is, I don't really know how to write like the length of the shadow. And so what I'm going to do is do a little bit of quick math, and then I'm going to reiterate what I'm talking about. Okay, so if I go cos theta is my adjacent, which is that shadow. Why don't I just call it shadow? The magnitude of the shadow. Okay, so it's that red line divided by the hypotenuse. Okay, so the hypotenuse, I mean, isn't that just however long v is? Okay, so I'm going to go like this. Vector v. All right, but I don't really want to know what cos theta is. I want to know what the shadow is equal to. So why don't we do like a quick cross multiply? And I'll have the shadow is equal to v magnitude times cos theta. So basically what happens is if I take, let's get rid of that because I think I know what that is now. The length of that red line is going to be the magnitude of v, cos, and then whatever theta is. Okay, so you're going to be like, Miss, you still have not really talked to us about what the dot product is. I did kind of tell you essentially what the dot product is when you take this guy and you multiply that guy. Okay, it's a projection of one vector onto the other, which is the red, multiplied by the magnitude of the other, okay, so which is in green. All right, so the dot product is right here. Did I say dot product? I meant dot product. Okay, and then you have each of the components, the green, which is the magnitude of u, and then also the red, which is the magnitude of the projection of v onto u. Okay, so those two combined together through multiplication is going to give you the dot product. And the product, if you think about the green component and the red component, every single component is not a vector. They're all scalar products. And so scalar, I should say, values. And so when you multiply this scalar value, and this scalar value, you're going to get an answer of a dot product, which is not a vector. It's going to be something we call a scalar product, which is just a number. Okay, so let me show you how that works. Example number 1. Let's say that they gave you the magnitude of u already and the magnitude of v already. Okay, so they said the magnitude of u is 4, magnitude of v is 5, and they're going to give you theta, the angle in between them. Okay, so the dot product, I've already written the formula at the top, and you just sub in the numbers. So this guy is 4. Okay, this guy is 5, and cos theta, which was 60. And then just multiply them all together, so then you get the dot product is 10. All right. Now the questions can get a little bit more tricky, so let me go through those with you. Let's just say that A is a vector of 3 components, B is also a vector of 3 components, and they have an angle in between them of 45 degrees. Okay, so determine the dot product. So I have the formula for a dot product, and notice that I've changed the u and v to a and b. And I can fill out the cos 45 part very easily. But how did I know what this was? Well, on the side, I would do some work and I would be like, okay, I know how to find the magnitude of a because I just do the Pythagorean theorem, right? Where I take each of the components, I square them, and then I add them all together. So it's 9 plus 4, that's 13, plus 1 is 14, square root 14. That's where I got this guy from. Now let's do the b. Magnitude of b is going to be each of the components, don't forget your brackets, squared, 4 squared, 1 squared, and then square rooted. So Pythagorean theorem, 64 plus 16 plus 1, I believe that's 81. And then that's going to equal to 9. Okay, so that's where this comes from. Then we're just going to multiply everything together, right? So 9 square root 14, cos 45 is 1 over root 2. And that's why I got the root 2 on the bottom. Now, what I'm going to do is like the same kind of communication marks that you guys had in grade 11, grade 12, they still count. And so I don't want any roots on the bottom. In grade 11, you learned about radicals. Okay, so let's get rid of that radical. I'm going to multiply it by 2 over root 2 is one way. Or if you don't even want to do it that way, what you can do is you can go root 14 over root 2. So that's going to be root 7. And therefore, my final answer in exact is going to be 9 root 7. Okay, let's keep going. So here are some more rules. I'm sorry, guys. I know it's a crazy amount of writing. Let's just explain. So on the left-hand side, what happens when your u vector and your v vector are perpendicular to each other? Well, if I have my sun and it's like right above, like this, it's going to try to project a shadow onto you. So we already have this guy, which is our magnitude of u. Okay, so that was this part right here, magnitude of u. But remember, what was in red was the projection. And so the projection is whatever the v was, okay, and then also you're going to have cos and the angle, 90 degrees. Okay? So you know what 90 degrees is when you take cos of it. It's just going to be 0. And so when you multiply it with these two other scalar amounts, well, you're just going to get 0. And that should make sense. Like if the sun is going to shine onto the vector v, it's not really going to make much of a shadow on the vector u. And so you're going to get 0 projection. Okay? Let's try that with the next one. Well, what if I have two identical vectors? And I think I wrote that wrong. That's not supposed to be a v, that's supposed to be a u. So let us rewrite that because we all make mistakes. All right. So what if I have two identical vectors, u, and I want to project them on top of each other? Okay, so what's going to happen is I have my magnitude of u. Okay, so we said that was the beginning, right? And then what happens if we have a sun? And it projects onto, well, the first u and seeing the shadow that then occurs onto the other u. We're going to have something like that. And so there's our shadow with an angle of 0 degrees because they're the exact same. You're just laying one on top of the other. Like there's no angle in between here. Okay, so 0 degrees, if you cos that angle, you're going to get a 1. And so if I simplify that, the dot product of u onto itself is u magnitude squared. So I want you guys to keep these two in mind because obviously we're going to get questions on them. Okay, so if you have two vectors and they're perpendicular, u and v, when they're dotted, is going to give you a 0. If you have the same product with the dot product of the same vector with itself, you're going to get an answer that is the square of the magnitude of that vector. Okay, now, taking that in mind, let's calculate some of the unit vectors. What happens if we dot them with each other? Okay, so for the very first one, why don't I get my purple out? Remember how we said that if you dot the same thing with itself, it's going to be the magnitude of that squared. That's what this guy said right here. Okay, so a unit vector's magnitude is going to be 1. 1 squared is just 1. And so the magnitude of basis vectors is going to be 1. Even if you use like the y-axis unit vectors or the z-axis unit vectors, you'll still get 1 and 1. All right. Now, what happens if you dot them with each other? Well, remember that if you're talking about the x-axis and the y-axis, they're perpendicular to each other. So you should get dot product of 0. And that should be true of any of these basis vectors that are unit vectors dotted together. Okay, so I'm just going to write that all basis vectors are perpendicular to each other. In other words, their theta is going to be 90 degrees, which then creates a dot product of 0. Okay, so here are some other properties where the dot product, if you do u dot v, it's commutative. V dot u will give you the same answer. You can distribute it, so you can take u dot anything inside a bracket, so whether it's a plus or minus, you can do u dot v plus or minus u dot w. Okay, now for the associative one, just be very careful. This is considered one thing. Okay, and so when you take a and you multiply it in, don't go twice. It means that you've doubled the a's. Okay, so just take the dot product first of the u and the v, and then take a and multiply that answer. Okay, so it really doesn't matter. I mean, you could even do a multiplied by the vector u and then dot v, or you can take a, multiply the v, and then dot the u. It really doesn't matter. And it's the same thing when you have like a larger number on the outside. Okay, this is going to look crazy, but I swear it's very intuitive. Okay, so you're like, I don't believe you. Okay, so here is vector u. Okay, and this is another vector u. We'll just say that these are two vectors, red and blue, and we're going to dot them. Okay, so this one's going to be my red. I'm going to dot it with the blue. All right, now this is what you do, and I'm going to do this with green so that you can see it. You're going to do a distributive law where a is going to multiply d, and the i's are going to dot because they're vectors. You can't dot a and d. A dot d just means that they're going to multiply each other because they're scalars. But the I, which is a vector, will dot the other I, which is another vector. Okay, so let's do the next one. Okay, we're just doing distributive law. We're going to share that AI with all of the 3 components in the blue vector. So you get A times E, I dot J. A times F, I dot K. Plus, then you're going to have to do this one. Whoops, I don't know why I went backwards. Okay, do these 3, and then you're going to do these 3. So messy. Okay, that should give you up until here. So that's just really, really, really long. All right, let's clean it up a little bit. I'm going to use a highlighter here. This guy right here, I dot I, we had said before, they're both unit vectors, and therefore when you dot them, they're going to give you the magnitude of I squared, which is just 1. Okay, that means that this guy, which is also a j dot j, will give you a 1 as well, because it's a unit vector dotted with itself. Here's the last one. Dotted with itself is going to give you a 1. any of the ones where the unit vectors are dotting each other, remember, gives you a 0. Okay, so there's a 0, there's a 0, there's a 0. And notice that I crossed them all out because they don't even really matter anymore. The only ones that matter are the yellows. So the AD, BE, and CF. This is a shortcut, guys. Basically what it's saying, this is a proof, and all I want to do is I wanted to show you guys. Let me write down the proof so that you have it. That if you take U and you dot it with V, and you have their coordinates, like it's in coordinate form, so U is A, B, C, and you want to dot it with D, E, F, then all you're going to get is you just take these guys, A and D, see, and you multiply them. AD plus B and E, see, multiply them. BE plus CF. Isn't that much easier? Okay, so essentially if you have everything in ordered triplet, that's not a word, ordered triple notation, take each of the components, multiply them together, and then add all of them, and you'll get one scalar product. Okay, so this should not be a vector. It should be an actual number. Okay, so it's going to give you a scalar. And let's see how that works. Okay, so I have two vectors. I have vector U, and I have vector V. So let's find the dot product in basis vector first on the left. Okay, so I got U dot V and I got the red and the blue. So I'm going to dot them both, which means that I'm going to multiply these guys together. So the 3 times the 2, and remember the I dot the I is going to give me a 1, so it essentially disappears. Plus this one and this one. So 2 times the negative 1, those are my coefficients. J dot J is equal to 1, so I'm not even going to write it. Last one, negative 1 coefficient times positive 1 coefficient is going to be negative 1. And the K dot the K is going to equal to 1, and so I'm not even going to write it. So the answer, when I simplify it, should equal to 3. So notice again, my answer is not a vector, it's a scalar amount. An even easier way is if we put it into the ordered triplet. And so take the coefficients of each of the components and put them into a vector like that. Same thing with your J, not J, V. Okay, and put them like that. And then you're going to take your X's, multiply them together, plus your Y's, multiply them together, plus your Z's, multiply them together, and you should get the same answer as the left-hand side. Okay, let's keep going. What if I asked you to find the angle between them? All right, so essentially what I'm asking you is on the right-hand side, I have a diagram. I don't want to go too high because I do want to show you something. I'm asking you for this angle. What is it equal to? Okay, so you have your projections, right? This one is going to project onto the U, which would be right there. That's the shadow. And then you also have the magnitude of U. Okay, so that makes up the entire dot product equation. So we have the dot products. I mean, this is example C. We're going to use the exact same answers as before. Didn't we already find the dot product, which is 3? I'm going to put that right there. Okay, so U, I'm going to scroll up a little bit more. We can figure out the magnitude, right? Where we're going to take each of the components, and then, you know what, where am I going to do this? Okay, so of the U vector, we have 3 squared, 2 squared, and 1 squared. Okay, and then we're going to do, is it 1 squared or negative 1 squared? Negative 1 squared. Okay, let's change that. Negative 1 in brackets squared. Beautiful. Okay, and then our magnitude for V was 2 squared, negative 1 squared, and 1 squared. And then this is what we're looking for, cos theta. We don't know what theta is, right? But now that's our unknown, so we can totally just solve. Okay, so 3 equals, that's going to be 14. Okay, and the blue is going to be, what is that, 4, 5, 6, root 6 cos theta. Okay, so these are all multiplying each other. Let's get rid of all of them. Root 14 and root 6. Got to do the same to the other side. 14 and 6. Okay, so we get cos theta, which equals 2, and I'm going to rewrite this because I want it to be exact. So theta is approximately 70.89 degrees. All right. Okay, lastly, 2 more questions. If I have 2 vectors, u and v, and they're perpendicular, what does that mean? Perpendicular means that the dot product is 0. We mentioned that before, right? When 2 vectors are perpendicular to each other, they equal to 0. Well, I'm going to take the dot product and notice that they are in coordinate form. So I'm not going to use this formula. The reason why is because I don't really have, they didn't give me an angle really. Perpendicular means 90 degrees, yes, but that just means I'm going to get a 0 here. And all of your unknowns will, you're going to have no unknowns essentially, okay? Because you can fill out the numbers here, and you're going to have no letters to solve for. So what I want to do, oh wait, no, there is an H. There's an H in there. Oh, that's going to be really tricky though. Isn't the H going to be stuck underneath the square root symbol? Yeah, no, I don't want to use this one at all. That's not a good one to use. We can use instead the method where we multiply the components together and add them. I think that would be much simpler. There's no there's no roots involved. And so if we take 7 times negative 3, we're going to get negative 21, plus 3 times 3, which is 9, 6 times h, 6h, beautiful. There's no roots at all. We know that this guy is going to equal to 0 because it's perpendicular, and we just solve for h, which is going to be 2. Okay, so we always have a choice as to which method we want to use. We can use the regular formula, or we can use this method as well. It really depends on what they give you in the question. So in this case, they gave us coordinate form, in which case I think it would just be easier not to use this formula. Okay, so last but not least, I've started it off. They've given us the magnitude of A vector, the magnitude of B vector, and also the angle in between. They want you to expand and simplify this expression. Okay, so they've dotted these 2 brackets together. And so what I'm going to do is I'm going to take this guy, multiply this guy. So I get 3 times 5, A dot A. Okay, now I'm going to take the 3, and you got to work with each one inside the bracket. So 3 times 6, A dot B. So essentially we're almost kind of like doing FOIL in a way. But the dot doesn't necessarily mean multiplication. I want to be very clear. The dot product does not mean a multiplication product in a way. Okay, so it's talking about a projection. 4 times 5, A dot B, B dot A, it's the same thing. And then this one, 4 times 6, B dot B. Okay, let's finish this off together. So we're going to get 15. A dot A is a magnitude squared, plus we're going to get 18, and I'm not going to expand this one yet. I'm just going to keep it as a dot product. We got 20 and the dot product of A and B, and then you got 24. And B dot B, let's just convert that into the magnitude squared. Okay, so the next part is, I know what A magnitude is. Isn't that 2 from the original question, like right up here? Squared plus, and why don't I put like this is the same as this. Okay, so I'm going to just add them together. 38 A dot B's. Okay, plus your 24, and you have your B magnitude already, which is 3, and that was being squared. Okay, so I think I might be able to figure out all these numbers. Now this guy is the one that's throwing me off a little bit. Why don't we do 38, and we'll convert this into like magnitudes that I can use. So since we were given the magnitudes of A and B and we were given the theta, well, that means that most likely I want to use this formula because it has each of the magnitudes and it has the theta. Plus the 24 with the 3 squared. Okay, and at the front I got the 15, 2 squared. Okay, let's move that up just a bit. Equals 2, and that entire thing is going to give me a 60. Why don't we start to substitute? A was a 2. Your B was a 3. And then it was a cos. How much was it again? 120 degrees. Plus 24 times 9. 24 times 9. 216? Times 9. Yeah. All right. And then keep going all the way. You'll get your final answer, 162. Okay, now later on we're going to have a video on the applications of the dot product. Maybe then we'll get into what it's actually used for. Right now, just think of it in terms of the formulas and the 2 separate methods that we can use in order to solve these types of examples.